So this next section is on the remainder theorem. Super, super straightforward and shortcut thing for us in very specific situations. Basically, when we're asked a question that says, is this a factor of, and then it gives us a longer equation. The only way that we would be able to do that up until right now would be to go through the whole process of the division and see if there's a remainder or not. Because if there's no remainder, it is a factor. If there is a remainder, then it's not a factor. All right. But if we kind of take some things that we should be piecing together, hopefully here, which is that if I have a graph, I have just a simple one like this, those two things right there are factors. All right. This and this are factors. They're also solutions. They're also x-intercepts. So when I have a factor, the y is equal to 0 both times. All right. So the y is equal to 0. That's the same thing as the output being equal to 0. All right. In a function, there's an input and an output. So the output's equal to 0. So if I have something that says, say, x minus 5, and it wants to know if that's a factor, it would be a factor if when I solve this, I would get x equals 5. If I plug in 5 and get 0 for an answer, then x minus 5 is a factor because when I divided it, that would be my remainder. So it's this nice little shortcut that I can use for a very, very specific thing. All right, if I have a question that just says, is this a factor of this? I can solve it, set it equal to 0 and solve it. Make sure you have to do that, set it equal to 0 and solve it. Then plug it into the original function. If you get an answer of 0, yes, it's a factor. If you get any other answer, that means you have a remainder and it's not a factor. Really straightforward, really easy question to answer.